In the quiet Shamiran district of northern Tehran, silence used to be a hallmark of security. However, Operation Epic Fury shattered that perception, marking a definitive turning point in modern conflict. This surgical strike was not a traditional military bombardment, but a calculated execution driven by base code and real-time sensing algorithms. As the first instance in history where artificial intelligence fully commanded the kill chain in a high-level decapitation strike, it proves that the modern battlefield is no longer defined by physical distance, but by digital visibility.
Operation Epic Fury marked a pivotal shift where AI moved from a supporting role to the primary decision-maker. While targets sought refuge in reinforced underground bunkers, they were actually enclosed within a global surveillance and strike network powered by the integration of Palantir, Anduril, and advanced language models. This represents the rise of software-defined warfare, where traditional, expensive military platforms are increasingly secondary to the algorithms that control them.
Palantir serves as the operating system for modern warfare, centered on its Gotham and AI platforms. The core objective is to dismantle the data silos that typically obstruct intelligence operations. Through a process known as ontology, the system maps chaotic battlefield data into intuitive digital objects, creating a living digital twin of the environment. This shifts the focus from reading static reports to interacting with a real-time common operating picture. By integrating satellite imagery, signals, and open-source data, the platform provides commanders with the ability to visualize tactical movements with mathematical certainty.
To manage complex operations under intense electronic warfare, Palantir sent its forward-deployed engineers directly into the field with U.S. Central Command. These tactical technicians worked alongside combat units, making real-time adjustments to satellite logic as mission requirements evolved. When a target moved, these engineers enabled instant cross-verification across multiple satellites, compressing the standard software update cycle from months down to just a few hours. This rapid deployment of code ensured the mission stayed ahead of shifting enemy countermeasures. To bypass Iran's total electromagnetic blockade, the mission utilized the hardened backbone of SpaceX's Starshield and the Milnet constellation. Even as ground-based networks were severed, this network of nearly 480 laser-linked satellites provided what commanders called digital oxygen, a high-speed encrypted data stream reaching 200 gigabits per second. By deploying man-portable UAT-222 terminals, special forces were able to push petabytes of imagery and signal data through the densest interference, feeding directly into the Palantir analysis engine to maintain a real-time tactical advantage. Moving into the cognitive layer, Anthropic's Claude became a cornerstone for synthesizing non-structured intelligence. Operating within isolated, classified networks, the Claude Gov model processed vast quantities of intercepted Persian communications to identify vulnerabilities in the Revolutionary Guard's command structure. This allowed analysts to simulate complex strike scenarios and predict escape routes during electronic suppression. However, the operation also exposed a fundamental friction between government needs and the ethical guardrails set by AI developers. This tension eventually led the administration to integrate xAI's models for a more aggressive, unrestricted approach to computational intelligence.
This transition toward what is described as the industrialization of assassination is driven by two primary AI systems, the Gospel and Lavender. The Gospel functions as an automated factory for infrastructure, identifying building targets at a pace hundreds of times faster than human analysts. In contrast, Lavender focuses on personnel, utilizing social network analysis and movement patterns to score and flag individuals on a massive scale. By shifting the burden of identification from deliberate human oversight to rapid algorithmic selection, these systems have enabled a level of lethal targeting that operates with unprecedented speed and volume.
Moving into the specifics of the AI kill chain, Slide 8 explores the controversial system known as Where is Daddy? This software represents a fundamental shift in tracking logic, moving away from monitoring military hardware towards tracking a target's domestic life. By alerting commanders the moment a flagged individual enters their residence, the system exploits the tactical vulnerability of a home over a hardened military facility. In the pursuit of the supreme leader, This algorithmic logic turned daily habits into a trigger for the final strike, prioritizing the elimination of the target regardless of potential collateral risks.
The shift toward autonomous air superiority is best illustrated by the integration of Anduril's Lattice and Shield AI's HiveMind. Instead of relying on traditional manned stealth assets, collaborative combat aircraft leverage edge computing to navigate complex threat environments autonomously. These drone swarms can detect radar locks and coordinate electronic counter-responses instantly, evolving their tactics mid-flight through real-time software updates. This transition to software-defined aerial warfare effectively renders hardware-centric defense systems obsolete, as the battlefield advantage moves from physical specifications to algorithmic agility.
Eagle Eye brings the power of the digital network directly to the tactical edge. Using mixed reality headsets developed by Anduril and Meta, special operations teams access a holographic interface that integrates the entire Lattice network into their immediate field of vision. This technology grants soldiers superhuman situational awareness, allowing them to track enemy movement through walls and monitor live drone feeds simultaneously. By bridging the gap between frontline operators and global intelligence, Eagle Eye ensures every person on the ground operates with a synchronized high-definition view of the entire battlefield. The landscape of national security is undergoing a fundamental transformation as Silicon Valley moves into the defense sector. A massive shift in capital, driven by venture-backed strategies like American dynamism, is now challenging traditional defense giants. Investment firms are pouring billions into hard-tech defense companies that prioritize speed, software-first development, and expendability. This model replaces the reliance on single high-cost assets with thousands of low-cost autonomous systems. Ultimately, this influx of private capital enables a higher tolerance for technical risk and facilitates much faster iteration cycles than traditional procurement allowed. Software-defined geopolitics operates across three distinct speeds. The military clock is now near instantaneous, reducing the time from sensor to shooter to mere seconds. Supporting this is the economic clock, which demands the rapid industrial-scale production of expendable AI weaponry. However, the political clock remains the slowest and most critical factor. While algorithms provide invincible tactical precision, they cannot automate regional stability or the winning of hearts and minds. Ultimately, the strategic limit of AI is not its lethality, but its inability to manage the human cost and complexity that follows. As the barrier to war lowers, these three clocks remind us that technology remains a tool, not a substitute for sustainable political resolution.